Hi, so let's look at binomial distribution. So we're going to the goal of this class is to use NumPy to plot the chart or to plot the graph at how it's going to look like. So that is the purpose or the essence of this class. So I'm not going into details about statistics like that. Or our target is NumPy, how to use it in different contexts, in maths, numerical computing, in mathematics. So that is the goal. So let us proceed and take a look at it. So the first thing is, I've already explained the difference between discrete and continuous data. So in this case, we are dealing with discrete data. So let me quickly import the stuff, all the necessary packages from NumPy. Okay, let me say import NumPy as what? As MP. Okay, from NumPy. Let me just say from NumPy, please. NumPy import random. Okay, and I think we don't need this one if we are already importing NumPy. I think. Well, let me leave it like that. Okay. So let me import cbon and matplotlib. So from matplotlib matplotlib dot pyplot. Import matplotlib dot pyplot. Oh, sorry. Let me say import. Let me just use import um import matplotlib dot pyplot. Okay, pyplot as what? PLT. Okay, then cbon. Import cbon as what? SNS. Let me just SNS. Okay. Now, so I say import numpy. you know. Okay. Let me just think. I might not need this stuff like this. Okay. Or maybe I can still import it. Okay. So let's look at what the main target of the day. So the first thing I'm going to show you is how to generate those points first. How to generate those points. Like when we say binomial distribution, for instance, let me just give an example here. Let me just generate another space. Okay. So when we say the binomial distribution, we are talking about like discrete values. Like let me just say a coin now. For instance, a coin is toast. Like you toast it about like you turn it around. I mean, you just toast it. Let's say 10 times. 10 times. You understand? So 10 times for a single experiment. So for a single experiment. So what are we looking at from a single experiment? We're talking about how many times. Let's say how many times. Let me just do this one. How many times? Many times head head shows up. Shows up. So we have for head and tail. So we have in a coin now. You have head and what tail and tail. For instance, head and tail. So we want to toss the coin 10 times now for that single experiment. So we're calling it an experiment now, and we're looking at how many times when we toss the coin 10 times now, how many times head shows up or how many times tail shows up, and you understand that probability of in once in the coin now probability, yeah, probability, okay, probability of a head or coin or tail, I mean, or tail is equals to what? 0.5. So 0.5. So you can see now. So that is one thing. So what are we considering everything now? Let me just put the parameter. So number one, you're considering number of times. Now n, which is number of times in a single experiment. Number two, what are we looking at? We're talking about, oh, sorry. So we're talking about, oh, sorry, you know. So we're talking about let me go back again. Okay. So we're talking about in a single experiment, the n means number of times we're considering number. So we're also looking at what? We're talking about probability p. P is the probability. Probability. Most times it's always equals to 5, 0.5, because half, or let me just say 1 over 2. So probability of one of the parameter, one of the option like head or tail showing up is 0.5. So then another thing you want to consider here, in a single experiment now, we are tossing the coin 10 times. So how many times are we going to conduct the experiment? So that is size. Let me just say, okay, let me call it size now. So how many experiments? Let me just call it how many experiments. So we are looking at how many experiments in this case now. So that is what we are going to look at. Like that's all the essence of all the way binomial distribution is. So now let me just give a simple example before I'll do the one of larger size. Okay, so let me just go to the next line. So now let me just plot, let me just try to generate some points now in certain experiments, and then I will now plot the chart. So this is it. So I will say so this is how you do it. Say random, so we're going to use the random. We have already import random from numpy from this place, from this place. So we have already imported random. So it's going to be random. You can see random now dot. So it has binomial. You can see binomial here. So the first thing I said is n. You have to define the n, the number of times in each experiment. So let me just say 10. Then how many, what is the probability of each of the parameters showing up? So you can define p now. You can say p equals to 0.5. Then and then size. How many times are we going to conduct it? So let me just take a small size because of I don't want too many stuff to be generated. So that is what we have now. So we're going to just equate it to x. Now let me just equate it to x, and then let me print x and see what we get. Print x. So and print x. Okay, so you have stuff like so. When we run the first experiment, we got 6. The first trial, we got 6 out of 10 out of this 10. We run it again, we got 7. We run it, we got 4, like that. So, but the running everything amounts to what 10 size. So you can run it 1,000 times. You can run it 10 anytime. So this is very crucial in decision making. Okay, so if you want to now plot the graph, now you want to show the charts, binomial distribution kind of chart. So it's going to be, so what you're just going to do is let's say I'm just going to say SNS, which is cbound. I want to use cbound to plot it. SNS dot what cbound this plot, distribution plot. So sorry, what am I getting there? This plot. Okay, so this plot. So what am I going to put? I just put the x inside. I just want to plot. Then I don't want it to just show one kind, something that is not so clear. So let me just use PLT now, matplotlib to show when we plot it. So let's run this line again and see. Oh, sorry, what's the problem there? This plot is duplicated. Okay, I think let me just restructure this. Let me see. Let me this. I think this plots. Okay, let's use that. Okay, this plot x. Let me check there. Okay, so I'm gonna run that and see what it gives me. So we are gonna look at that. So not this is this plot, distribution plot like this. Sorry, I think I've gotten it now. Let me run it and see what it gives me again. Okay, so you can see the plot here right now, but the points are very few. That is why it's not giving me something like a bell curve. So you can set to increase the number of points there right now. So now let me increase it to 1,000. Let me increase the size, number of trials size to 1,000. So I'll run it again. Let me just run. Please permit me to remove that x out so that it will not generate all the numbers so much there. So I'll run this one, then I'll run this one again. See what it gives me. So let's look at it now. Scroll down. So you can see as almost like a bell curve now, like a bell curve if you plot a curve over it. So that is for binomial distribution. I hope you understand this simple explanation. It's not a deep dive into statistics, it's just for you to know how to use NumPy to construct a kind of binomial distribution curve, okay, or chart. So thank you very much. I'm going to stop here right now. Look forward to seeing you next class and stay tuned.